This proof, we're going to see some different information. We see the word bisect, which also has a special meaning to us. And we see the diagram is back to having two triangles that share a side, which is going to be important for us soon. So let's go to our given information. That's always a good place to start when we're trying to prove some things. In this case, that the two triangles are congruent. And in our given information, we see that we have a segment AD in our picture. And this particular segment is doing something. It is bisecting. And so recall that bisect would mean to cut into two equal parts, two equal halves. And so all we need to do is read what is being cut in half. And so we see that AD is bisecting two different things. It's bisecting angle BAC. And remember, to find that angle, we just trace the letters from B to A to C. In other words, we're talking about angle A, the letter in the middle. And so we were just told that this angle A was cut in half. And if we look at the diagram, we can see that here's angle A, and there are two smaller angles making up this angle. The angle that's above the segment AD and the angle that's below segment AD. And so the word bisect is telling us that these two angles are congruent to each other. So again, the reason is not given. The reason is that in our given information, we had that keyword bisect. So this is definition of angle. You can either write the word angle or use the symbol. Definition of angle bisector. Okay. Now, if you read carefully, you see there was a second piece of given information. It's that something else was also cut in half. It was angle BDC, which again, if you trace from B to D to C, we're talking about angle D over here, the vertex. And again, if we look, we see that angle D has been split into two parts. We have the angle above segment AD and the angle below segment AD. And the word bisect is telling us that these two halves are equal to each other. And so just like the first diagram, we have definition of an angle bisector. And so our given information was talking about two angles being bisected. So we see that same reason happening twice. I forgot to come over here and mark our diagram. So here we go. We've marked these angles as congruent, and we marked these as congruent. And so we have two pairs of angles congruent, meaning we are to the point of either needing to use the theorem angle side or angle side angle to prove these triangles are congruent, because these two theorems each use two pairs of angles, which is what we have marked so far. And so we're out of given information. We need a guarantee. And again, we have very few guarantees. It basically boils down to, do you have vertical angles? Because that's a guarantee of congruence. Or do you have two triangles that share a side? They have the same side. They have a side in common. And the answer is yes here. They both use segment AD as their sides. It's the bottom side of the top triangle, and it's the top side of the bottom triangle. And so they both use that side. So of course, if they have this side in common, it's the same length for both of them. So yes, we say it's congruent to itself, and that is always the reflexive property that says we can. And now that we've done that, we see that we have two congruent triangles. Triangle ABD is congruent to triangle ACD. And the reason is our theorem of angle side angle, because we have two pairs of angles marked, and the side that's connecting us between those two angles is also marked.